Hi everyone. Today we're briefly going over the coefficient of determination and standard error of the estimate. Some important terminology to know on these slides are explained, unexplained, and total variation, residuals, the coefficients of determination and non-determination, prediction interval, and standard error of the estimate. Feel free to refer to these definitions if at any moment you are confused. Now let's get into the lesson.
Finding the three types of variation. To find the three types of variation, we have to find the predicted values using the line of regression equation. Plug in the x values with the given equation, 4.8 plus 2.8x. Then we calculate the mean of the given y values. Next, we use the total variation equation, which is the sum of the y minus the mean of the y squared. The explained variation equation, which is the sum of predicted y minus the mean of y squared. And the unexplained variation equation, which is the sum of y minus predicted y squared. You can notice that the total variation is equal to the sum of explained variation with unexplained variation.
Coefficients of determination and non-determination. To find the coefficient of determination, you can either use the explained variation divided by the total variation as shown through these slides, or the squared given correlation coefficient. For the coefficient of non-determination, you first find the coefficient of determination and then subtract it from 1.
Standard error of the estimate. There are two methods to find the standard error of the estimate. One uses the unexplained deviation and the other uses x and y. Using this example, we can make a table with the x values, y values, predicted values, the differences of the y values minus the predicted values, and the squared answers of the differences of the y values minus the predicted values. For method 1, find the predicted values using the regression line equation. Then, subtract them for each y value. Finally, square each difference, add them together, and then plug it into the equation. Using the same problem, for method 2, make a table with the x values, y values, products of the x and y values, and the squared answers of the y values. Find the product of the x and y values, square the y values, add them all together, and finally plug them into the given equation. The difference between using method 1 and method 2 is the rounding.
Prediction interval. To calculate the prediction interval, we will use the following equation. The first step would be to calculate the sum of all the x values, the sum of each individual x value squared, and the mean of the x values. Next, we plug in 3 for the x value in the regression line equation, which is given to us in the problem. Using the t-table, find the critical value for 95% confidence and 4 degrees of freedom. Using all of the values we have collected, input it into the prediction interval equation, and you should get an interval of 60.53 and 99.39. So we are 95% confident that this interval contains the actual y value.
Now, how can we use this lesson in the real world? One example is agriculture, with the relationship between the amount of sunlight a plant receives and its growth. Another example, relating to the experiment, is the relationship between each pH environment and the germination rate of the beans. We can use line of regression, coefficients of determination, and standard error of the estimate to understand the benefits of each of these relationships. And that concludes our lesson. If you have any questions, please email us, and thank you for listening.